Formula One, commonly known as F1, is one of the most prestigious and exhilarating motorsports in the world. With its roots dating back to the early 20th century, F1 has evolved into a global phenomenon, captivating millions of fans with its high-speed races, cutting-edge technology, and iconic drivers. The foundation of Formula One can be traced back to the early 1900s, when automobile racing first captured the imagination of enthusiasts worldwide. The Paris to Rouen race in 1894 is often considered one of the earliest motorsport events, followed by prestigious events like the Targa Florio in Sicily and the Gordon Bennett Cup, which attracted competitors from different nations. The 1920s and 1930s marked the rise of Grand Prix racing, with events organized in various European countries. Legendary circuits like Monza, Silverstone, and Monaco hosted thrilling races that pushed the boundaries of automotive technology. Drivers like Tazio Nuvolari and Rudolf Caracciola became household names, mesmerizing spectators with their daring maneuvers. The term Formula One was officially adopted in 1946 when the Fédération Internationale de l'Automobile (FIA) introduced a set of regulations to standardize the technical specifications of racing cars. The inaugural World Championship season took place in 1950, featuring 7 races across Europe, with Giuseppe Farina becoming the first F1 world champion. The 1960s and 1970s witnessed a golden era in Formula One, characterized by fierce competition, innovation, and some of the most charismatic drivers in history. Icons like Juan Manuel Fangio, Jim Clark, and Jackie Stewart left an indelible mark on the sport. Advancements in aerodynamics and engine technology led to faster and more powerful cars, captivating fans worldwide. The 1980s brought both triumphs and tragedies to Formula One. The sport mourned the loss of talented drivers like Ayrton Senna and Gilles Villeneuve, which led to a heightened focus on safety measures. The introduction of carbon fiber chassis, improved helmet designs, and changes to track layouts contributed to making F1 significantly safer for drivers. The 1990s and early 2000s saw unprecedented technological advancements in Formula One. The sport became a laboratory for cutting-edge engineering, with a relentless pursuit of aerodynamic efficiency and the increasing use of computational simulations. Teams invested heavily in research and development to gain a competitive edge. Michael Schumacher and Ferrari dominated Formula One in the early 2000s, achieving an unprecedented level of success. The German driver secured 7 world championships, while Ferrari enjoyed a period of dominance, both on the track and in terms of fan following. The year 2014 marked a significant shift in F1 engineering with the introduction of hybrid power units. These turbocharged V6 engines, coupled with energy recovery systems, ERS, emphasized sustainability and fuel efficiency, aligning with the global push towards environmentally friendly technologies. In recent decades, Formula One has expanded its reach, hosting races in various countries across the globe. The sport's commercialization has also skyrocketed, attracting sponsors and immense media coverage, making it one of the most watched and followed sporting events in the world. As Formula One enters the present day, it continues to face challenges and opportunities. Striking a balance between pushing the boundaries of technology while maintaining competitive racing remains a delicate task. The sport's governing body, FIA, continuously adapts rules to ensure safety, fair competition, and sustainable practices. Aerodynamics is the backbone of Formula One engineering, defining the fine balance between speed, handling, and performance. Over the years, F1 teams have invested heavily in cutting-edge advancements to optimize aerodynamic design, making the difference between winning and losing on the track. Aerodynamics refers to the study of airflow over and around objects, and in the context of Formula One, it is paramount in shaping a car's performance. By manipulating the airflow, F1 engineers aim to achieve maximum downforce, minimizing drag, and enhancing overall stability. Downforce ensures that the car maintains traction and grip, allowing it to navigate corners at higher speeds, while reduced drag optimizes straight-line performance. Front and rear wings are critical components of an F1 car's aerodynamic package. The front wing serves as the first point of contact with the airflow, directing it over and around the car. It generates downforce to stabilize the front end, aiding in cornering and steering responsiveness. The rear wing works in conjunction with the front wing, balancing downforce distribution and providing additional stability. Diffusers are an essential part of the underbody aerodynamics in F1 cars. Located beneath the car, they work by accelerating the airflow and creating a low-pressure zone, resulting in ground effect. This generates substantial downforce, particularly in the rear of the car, further improving traction and stability. Computational Fluid Dynamics (CFD) is a computer-based analysis technique that models and simulates fluid flow, allowing engineers to predict airflow behavior and visualize aerodynamic performance. It enables teams to explore countless design iterations virtually, saving time and resources compared to traditional wind tunnel testing. Although CFD simulations have become more prevalent, wind tunnel testing remains a crucial part of aerodynamic development. Wind tunnels allow engineers to validate computer-calculated data and fine-tune designs in real-world conditions. Correlation between predictions and wind tunnel results ensures that the virtual simulations accurately represent the car's actual behavior on the track. Formula One's governing body, the FIA, periodically updates regulations to maintain competitive balance and control costs. These regulations often impact aerodynamic design, influencing the size and shape of wings, diffusers, and other aerodynamic elements. Teams must adapt quickly to these changes to stay competitive. Aerodynamics not only influence car performance but also play a pivotal role in race strategy. Teams must strike a balance between downforce and straight-line speed, depending on the characteristics of each track. This strategic decision-making adds another layer of complexity to F1 racing. In Formula One, the quest for speed, agility, and handling prowess drives engineers to explore innovative solutions to reduce the weight of racing cars. Lightweighting is an integral aspect of F1 engineering, where the use of advanced materials such as carbon fiber, titanium, and composites plays a vital role. The weight of an F1 car directly influences its acceleration, braking, cornering ability, and overall performance on the track. To gain a competitive edge, engineers meticulously assess every component to reduce mass while maintaining or enhancing structural rigidity. Lightweighting allows for better power-to-weight ratios, increasing speed and maneuverability. Carbon fiber is a key material in F1 lightweighting strategies. It is known for its exceptional strength-to-weight ratio, surpassing traditional materials like steel and aluminum. Engineers use carbon fiber to construct chassis, body panels, wings, and other critical components, as it significantly reduces overall vehicle mass without compromising structural integrity. Titanium is another favored material in F1 engineering, particularly for high-stress applications, where strength and lightness are paramount. Suspension components, gearbox components, and engine parts benefit from titanium's resilience and low weight, allowing for improved performance under demanding conditions. Beyond carbon fiber and titanium, F1 engineers utilize advanced composite materials to enhance lightweighting. Fiber-reinforced flanges. F1 engineers must strike a delicate balance between weight reduction and maintaining structural integrity to withstand extreme forces during high-speed races. Safety standards set by the FIA place strict requirements on crashworthiness and survivability, which further complicate lightweighting initiatives. The chassis is the main structure of the car, which includes the cockpit, the bodywork, the suspension, and the aerodynamic components. The chassis must be made from composites of carbon fiber and similar ultra-lightweight materials, which are strong and durable. The minimum weight permissible for the chassis is 1,631 pounds or 740 kilograms, including the driver, but not fuel. There is no upper limit in terms of the weight of a Formula One car, however it is highly undesirable to be overweight. Increasing the weight makes the car slower, so teams aim to get as close to that lower limit as possible. The cars are weighed with dry weather tires fitted. The dimensions of the chassis must be maximum width of 78.7 inches or 2 meters, a maximum height of 37.4 inches or 0.95 meters. There is no specified number for maximum length, but all cars tend to be of almost the same length of 216.5 inches or 5.5 meters long. The chassis must also comply with various safety standards, such as crash tests, fire protection, rollover protection, and cockpit protection. The engine is the power unit of the car, which consists of an internal combustion engine, ICE, a turbocharger, a battery, an energy recovery system, ERS, and a control electronics unit. The engine must be a 97.6 cubic inch or 1.6-liter turbocharged V6 hybrid engine, which can produce up to 1,000 horsepower. The engine must also have a maximum fuel flow rate of 26.4 gallons per hour or 100 kilogram per hour and a maximum fuel capacity of 29 gallons or 110 kilogram. The engine must also follow certain restrictions on its development and usage, such as a limited number of components per season, a limited number of engine modes, and a limited amount of fuel energy per lap. These rules are intended to reduce costs, improve reliability, and promote sustainability. The tires are the only part of the car that makes contact with the track surface, and they play a crucial role in The tires must also have different compounds and colors to indicate their level of hardness and durability. The teams can choose from 5 dry weather compounds, C1 to C5, 2 wet weather compounds, intermediate and full wet. For many years, this exhilarating sport faced significant safety concerns due to the inherent risks associated with high-speed racing. In response to several tragic accidents, the FIA introduced the Halo design, a groundbreaking safety feature that has revolutionized F1 car engineering. The concept of the Halo design originated in the aftermath of the fatal accident of Jules Bianchi at the Japanese Grand Prix in 2014. The young French driver's collision with a recovery vehicle underscored the need for additional safety measures to protect drivers' heads in the event of an impact. After extensive research and consultations with experts, the FIA introduced the Halo device for the 2018 F1 season. The initial design was a 3-pronged titanium structure mounted to the car's monocoque, positioned above the driver's head. Its primary function was to deflect large debris and offer protection against potential head injuries in certain types of accidents, such as high-speed collisions and airborne objects. Although the Halo design faced criticism for its aesthetics and obstructing the driver's view, the FIA's commitment to safety prevailed. In the 2018 Belgian Grand Prix, the Halo was put to the test when Fernando Alonso's car was launched over the top of Charles Leclerc's Sauber. The Halo absorbed the impact, preventing what could have been a catastrophic head injury to Leclerc. Similar incidents have occurred in subsequent seasons, further validating the life-saving potential of the Halo design, and drivers now appreciate the sense of security it provides. Formula One continues to captivate audiences worldwide with its adrenaline-pumping races and cutting-edge technology. The sport is gearing up for a dynamic and transformative future. By analyzing current trends and developments, we can gain insights into the exciting prospects that lie ahead for the pinnacle of motorsport. The future of Formula One will undoubtedly be shaped by continuous technological advancements. F1 engineers and teams are relentlessly pushing the boundaries of innovation to enhance performance, safety, and efficiency. The use of artificial intelligence, machine learning, and big data analytics will become more prevalent, providing teams with real-time insights to optimize car setup, driver performance, and race strategies. In response to global concerns about sustainability and climate change, Formula One is embracing greener practices. The introduction of hybrid power units in 2014 marked the beginning of a more environmentally conscious era. The future of F1 will likely see a further emphasis on sustainable fuels, greater energy recovery systems, and reduced carbon emissions to align with broader environmental objectives. Electrification could revolutionize the sport, with the adoption of all-electric powertrains, offering new opportunities for technological breakthroughs, cleaner racing, and a unique form of competition. Formula One has been increasingly diversifying its global reach by expanding to new markets and attracting a broader fan base. The sport's potential growth in Asia, the Middle East, and the Americas could open up new opportunities for exciting racing venues, increased sponsorship, and heightened fan engagement. The future of Formula One will likely witness the integration of virtual and augmented reality experiences for fans and teams alike. Virtual reality simulations could enhance fan engagement, allowing viewers to immerse themselves in the world of F1 and experience races from different perspectives. For teams, augmented reality could revolutionize car development and enhance race strategy. While the driver remains a central figure in Formula One, the future may bring advancements in autonomous racing technologies. Autonomous capabilities could assist drivers, enhance safety, and open up new avenues for innovation in racing. Safety innovations, such as improved crash protection and biometric monitoring, will continue to be at the forefront of F1 development. Thank you so much for watching this video. If you enjoyed this video, make sure to hit the subscribe button and turn on the notification bell. Also, remember to give us a like so we can continue making content that you love. Thank you.